Hello and welcome to this video about Python for data handling. In this video lecture, you will learn about the dictionary, which is a Python native data storage abstraction, or you could say Python data storage abstraction. The Python dictionary provides speed, data key pairings, and ensured uniqueness of dictionary keys. When using Python and/or Pandas for data handling, dictionaries are often used to create mappings for name changes, mappings for transformations, or mappings to create input for Pandas data frames. Dictionaries are also frequently used as an effective tool to create mappings between data items or values and translations such as colors in plots and graphics, or to create labels for classes. Dictionaries are a very useful tool to know for data handling purposes. Now we'll talk about the Python dictionary data type, and the dictionary is a collection that requires data to be stored in key plus value pairs. And the dictionary is a quite modern addition to current programming languages and is mainly used for speed and the ensured uniqueness of keys within collections or data sources for data science analysis or machine learning tasks. The enforced uniqueness of keys is very useful for data security in data handling tasks and may, for example, by design, prevent multiple values where uniqueness is required or wanted. The properties of the Python dictionary are that dictionary items, which are key plus value pairs, are ordered by the insertion order, changeable, and that dictionaries don't allow duplicates of dictionary keys. A dictionary key is restricted to strings, numbers, or tuples with arbitrary values, as long as the values are immutable with some restrictions to the object types. Dictionaries are indexed by their keys and may have any current Python object as data values, including other collections or even Python dictionaries. And on the screen, you can see an example piece of code that shows some Python dictionary code and is a fictitious mail catalog where a person's fictitious name is used as a string key and a fictitious mail address is used as string data or string values. Now we'll type some Python dictionary code. So let's start up your code editors. All right, having started our code editors, we will type some Python dictionary code. And we will start by typing the string object mail catalog code example from the PowerPoint. So we will begin to type Python dictionary. And we will create a Python dictionary with 3 key value pairs consisting of a string key and a value string. We type mailcat equals Joe for the first key and joe.joe@gmail.com. We add the second key as an and, and we add the third key, Lisa, and we will print our male cat, and we will print the type of our male cat. So let's run this code. And here we can see that we have the class dictionary, and we can see that we have our dictionary with 3 key value entries. And the first thing we'll do is that we will add a new instance Muhammad to the dictionary. We type male cat Muhammad equals Muhammad@gmail.com, and we can print the male cat. So let's run this code. And here we can see that we have added a new instance of key value pairs to the dictionary. So here we have the key Muhammad, and we have the string value of this Gmail address. So here we can see that we can add new instances using assignment. And we can say that a dictionary is created with a name, the equality sign, and 2 curly brackets. We have the name of the dictionary equals something within these brackets. What we'll do now is that we will add an integer key string instance to the male cat to show its versatility. We type male cat 5 equals, this is a string with an integer key. And we can print the male cat. So let's run this code. And here we can see that we have added a key, integer 5, and a string. This is a string with an integer key. Now we will show some ways to address and print the dictionary keys and items. We print mailcat.keys. We can print mailcat.values. And we can print mailcat.items. And this will print the dictionary's key value pairs as a list of tuples. So let's run this code. And here we can see that we have the dictionary keys printed. So here we have the keys as a list. Here we have the values. And here we have keys and values when we refer to the dictionary's items. And we have some more methods, or you could say functions. We can print, for example, mailcat.lisa, which refers to the key Lisa. And this will print the value of the Lisa key value pair. And we can print mailcat 5 and this will print the value for the key integer 5. And we can also print mailcat.get. Lisa. And this will return the value for the key in the dictionary. And if not found, it will return a default value. And here we can say that it is important that you note that key names must be correctly specified with upper and lower case characters wherever appropriate. And this is quite different from mail addresses, because mail addresses tend to always be lower characters. So you can type them with upper characters, but when you use them, they will always be interpreted with lower characters. So let's run this code. And here we can see that the value for Lisa is lisa@gmx.com. The value for 5 is this is a list with an integer key. And the return for get Lisa is lisa@gmx.com. All right, now we'll talk some about changing the value for a key in the dictionary. And this is done with assignment. So we type to change a value in the dictionary. Assignment can be used. For example, we can type mailcat Joe equals Joe to Joe 2 at gmail.com. And we can print our mailcat. So let's run this code. And here you can see that Joe.joe was changed to joe2.joe2. And for example, if we want to delete a key value pair or an item, type delete mailcat 5, and we can print our mailcat. So let's run this code. And here you can see that the key 5 with its value has been removed from our dictionary. All right, now we're going to type some advanced dictionary functions. And we must say that if these functions feel complex or advanced or even hard to grasp right now, we recommend that you return to this video after completing this entire video and Python section. So when you have completed this section, you return to this video lecture, and if these functions still feel complex, you can try the Pandas section or course and return again. And all will be clear with some practice and exercise. And as you know, practice and exercise makes the master. All right, we will start with the length function. Which returns an integer describing the number of items or elements in a dictionary. We can type print the length of the mailcat. So let's run this code. And here we can see that we had the integer number 4 returned, and we have 1, 2, 3, and 4 key value instances in our dictionary. And we can use the string function to cast or you could say create a string of the entire dictionary. And we can say that this may be useful in some text mining applications. So let's type print string mailcat. And we can print the type of the string of the mailcat. And we can say that this will return a string within curly brackets. So let's run this code. And here we can see that we have the class string for this object and that we have a string within curly brackets. And now we'll test some loops on our dictionary. And we will primarily use for loops. We can type that this for loop iterates through all the keys in a dictionary, and the function will print each key on a new line. We type for M in mailcat, print M. And here we can say that the default for the dictionary when we type print M is the key. So let's run this code. And here we can see that we have our 4 keys printed, each on a new line. And we can do this explicitly. We type 4k in mailcat.keys. Print k. So let's run this code. So here we can see that this instruction, in principle, we could say executed the same work, but it actually didn't do exactly the same work, but it created exactly the same result for this dictionary. And we can say that we can print the values in the same way. We can print for we in mailcat.values. Print we for value. So let's run this code. And here we can see that we printed the values of our dictionary. And now we will type a loop that iterates through all key value pairs in our dictionary and prints each key value on a new line. We type for key and value in mailcat.items. Print key and value. So let's run this code. And here we can see that it printed the key and the value, the key and the value. So now we'll talk some about nested dictionaries. And these are very complex constructions that exists nowadays because programmers tend to enjoy to create advanced databases and advanced object-oriented constructions. And what you sometimes end up with is dictionaries of the nested type, where, for example, one dictionary may hold a number of, or even a hierarchy of nested dictionaries. And this can be very efficient when you code it to store data, because you can create a lot of nested dictionaries which can handle, for example, sparse data matrices. But when you extract this data from the database, if the programmer hasn't taken account and created functions for all possible scenarios, which they never do, then you could have a data handling issue with these nested dictionaries. And these issues can take many different dimensions. One is that you can get a matrix of data which is a lot more sparse than it should be. And the other is that you get the nested data in a nested fashion, and that you will have to execute very advanced data handling in order to actually use the data. And for most university-educated programmers and data analysts, there is a huge gap between the requirements to properly analyze these databases and their current capabilities to actually do so. So here we will teach you very valuable information. So all right, let's begin. Nested dictionaries. And we will create a dictionary inside our current dictionary. So we type mailcat, special mail, equals a dictionary, and the first key is Rolf, and we create a second key, Anne, and we close the dictionary, and we can print our mailcat, and we will cast it as a string. And we can say that this is a nested dictionary with a complex multi-type structure. So let's run this code. And here we can see that our nested dictionary has been added to our dictionary. So here we can say that we have a dictionary with a double structure. So you have an ordinary dictionary and you have a nested dictionary. And this creates a complex object-oriented data structure. And we can say that currently there is no inbuilt, easy accessible Python function to handle these multi-type structures. And this means that you will have to write all the code yourself to handle them. And the first thing we will do is that we will type a for loop using the direct known address of a part of the multi-type structure we type for key and value in mailcat specmail. We can type name and address equals key and value. And we can print the name and the address. All right, this code will iterate only over a small part of our dictionary, and we will only iterate over the specmail part of the dictionary. And this is what we specify here in the first part of the for loop. And the second part is that we will only iterate over the items. And this makes sure that we will only iterate over key and values. And in the second part of the for loop, we will unpack the key and the value to name and address, and we'll print the name and the address. So let's run this code. And here you can see that you have the key and the value of this nested dictionary. So what you can do with this for loop is that you can extract this information and you can put it into a new dictionary and you can add these dictionaries together. For example, manually or automatically. And this is a bit interesting, so we can continue to type and we can use keys and direct known addresses on exactly defined part of the multi-type structure. And we can say that this has many different solutions. So there probably are 10 or 20 different ways to type this solution. So we can print the list, mailcat, specmail, keys, and here we can put a 0 and we close the print instruction. And we can print mailcat, specmail, roles. And what the first line does is that it takes the mailcat, limits it to the nested dictionary and its keys. And it takes this part of the dictionary or the output or return of the keys function, cast it as a list, and selects the first element of that list, and it prints it. And this will be Rolf. And this other instruction does the same thing, but it points directly at Rolf. And this Rolf will return the value, which is Rolf's mail address. So let's run this code. And here we can see that we have the key and we have the value. And we can extend this to automation. So we can type that here we have a not so Pythonic automation variant, which makes it possible to list and address key value pairs using list position notation. And when we say that the code we will type now is not so Pythonic, means that it is complex and it is overbearing and it uses several casts or conversions to achieve a very useful result. We can type print list mailcat. We point at the spec mail. And we will only use the keys. And the second thing we will do is that we will print the mailcat spec name this. We can take this code and we can simply cut and paste it. And we can change zeros to ones. Because as you remember, in this nested dictionary, we had 2 entries and not 1. So let's run this code. And here you can see that we have the key and the value and the key and the value. And this is very useful because now we can address and point at each element and we can create almost arbitrary solutions to collect all information in these nested dictionaries. And the only thing which is bad with this code is that it is non-Pythonic. And this means that it is complex and that it uses a large number of steps to achieve its results, and therefore becomes hard to type, hard to read, and a bit tough to understand. Yet this code is very useful. And now we'll show a Pythonic way to automate the flattening of the Mailcat dictionary to a standard dictionary. And we will delete the nested dictionary. So now we'll show you how to handle exactly this type of nested dictionary and turn it into a you could say unitype or standard dictionary, which you can analyze and use with standard data analysis tools and all such things. So let's type use a Pythonic automation variant to flatten the Mailcat dictionary to a standard dictionary and delete the nested dictionary. So we type for K and V for value in Mailcat spec mail items Mailcat K equals value. And we will delete Mailcat spec mail. And we'll print the resulting Mailcat. So let's run this code. And here we can see that we have a ordinary Python dictionary where the keys and the values of the nested dictionary has been assigned to the standard dictionary. And as a final part of this, you could say, transformation, the nested dictionary was deleted. So right, now we will talk some about how to clear or delete a dictionary. And the first thing we will do is that we will use the clear instruction to delete all elements or items in a dictionary. We can print the Mailcat and we will see what remains. So let's run this code. And here we can see that all we have is an empty dictionary, which is represented here by two, you could say, brackets. And now we will delete Mailcat. And we can try to print Mailcat after deleting it. And this will return an error because there is no Mailcat anymore. So let's run this code. And here we can see that the delete instruction removed the male cat from memory, and therefore the name male cat is no longer defined. So, all right. In this video lecture, you learned how to use Python dictionaries, and you learned a lot of useful and advanced knowledge about dictionaries. And in the next video lecture, we'll teach you even more. And we look forward to see you in the next video.